Captain Cutsey, we're in our climb out of flight level 200 for flight level 320. This is part 2, volcanic ash. Let's go dynamic. And while we are proceeding directly on course, we will cover a few items that we didn't talk about in part 1. We are tracking our flight, as you can see here on the Jeppesen map, and it's synchronized to my simulator. Airlines have their own SOPs. What I'm going to cover here is just a brief look at one airline's operational procedures, which are excellent, really, and all airlines should really follow this airline's example. An explanation of volcanic ash, and we've already looked at that. Now, these contamination levels have been defined below. Areas of low contamination, ALC, area of medium contamination, AMC, and area of high contamination. These are what you would see within a NOTAM to give you an idea of the grams per cubic meters concentration. High contamination, as defined by NOTAM, which contains ash at densities considered unsafe. Simple. Your dispatch center and you as the crew members are responsible. Flight within the defined volume of VATDA is prohibited. All right. The volcanic ash concentration charts normally depict the VATDA as a red area. That's why I've highlighted this text in a gentle background of red. This is advisory only and may not coincide with the area described by the definitive NOTAM. And as you remember, yesterday we had a look at an example of a sample NOTAM with Latin long dimensions. So be careful with those, and that's what this statement is making. In other words, the concentrated area, depending on the winds and the strength of the wind and the change of winds at different levels, the concentrated mass will move and shift. Crews have the options of flying over, under, or around these areas. Now remember, this is one airline's SOPs, but they are very much part of sound airmanship. Flight beneath VATDA is permitted in accordance with these criteria. The maximum flight level will be 2,000 feet below the lowest limit of the VATDA. A careful check of the MSA, of course, must be made to ensure flight under the VATDA can be completed at the maximum flight level defined in the first statement. On your JEPI charts or Lido or whatever charts you're looking at, you do have the MSA sectors that you can use with reference on the route to know what you're safe to go down to, what the MSAs are, etc. So here we are in an area of 8,800 feet as an MSA. I stand to be corrected on that, but that's what I'm reading here. So you depending on what equipment your company has issued you, let's say if you have an iPad and you have this capability, you can flight follow. But you also have your nav map here that we're looking at. And you know from your flight plan data also what the minimums are along the route. And in the actual layout of the MORA, minimum obstruction reception, or minimum operational reception altitude and operational altitude, you have that listed. Most critical is 8,000 feet, let's say at Comox on this particular clearance. So it's important. You have a column here in this flight plan, which is following the Lido format, incidentally, of MORA and of 8,000 feet over Comox. All right, and then Port Hardy, it's 3,600 feet, and etc. So you are really responsible for that when you are flying. So we'll just zoom in a little wee bit here. We're coming up over Comox now, and we'll continue with our briefing. Let's go back to what we were discussing. So that's the area of high contamination. The overflight prior to departure, crews must consult with the latest snow temps, of course, and volcanic ash concentration charts, which should be available at Crew Report or whatever your company has set up at dispatch. Company policy for this company is that only VATDAs with an upper specified limit of flight level 200 may be overflown. So remember, this is one particular airline's SOPs. You follow your airline's SOPs. The reason why I've chosen this company's SOPs is I feel they're by far the best in the world. The flight must be planned to overfly any VATDA at a minimum of flight level 250 and must be established at or above flight level 250, not to exceed 20 minutes duration. Let's just have a look at where we are here. We are now in VNAV path, FMC speed, LNAV, and we are cruising at the planned cruise Mach. And we are just coming up over Comox. So now is the time to refer to the flight plan and check fuel, etc. And we'll just fly the airplane here. All right, there we go. And we'll say that the fuel is complete. Fuel check is complete. I've just got another lovely piece of software for training purposes. Is a blown up copy here of the FMC so we can better see it. The pilot flying, in this case, the captain is the pilot flying, and we're right bang on our target speed. This little selection here lets us know what the legs page looks like, and we can go over there and look at the progress of the fuel. So 8.5 fuel when we are over, and that checks out with respect to the flight plan. All right, let's go back to our briefing. Here again, the flight must be planned to overfly any VATDA at a minimum of flight level 250 must be established at or above flight level 250, a minimum of 30 miles from the boundary of any VATDA. That allows ample room to safely conduct the flight. And the period of VATDA over flight should be operated at high-speed cruise, and it should not exceed 20 minutes duration. These are important. In the event of a loss of cabin pressure whilst overflying VATDA, the MSA must be nominated as the top of the promulgated VATDA. Now that's important. in the event of a loss of cabin pressure. Remember, we talked about these things yesterday in the last video. All the different multiple failures that you may have using volcanic ash, flying in an area of volcanic ash. Let's have a quick look at what's going on here. We'll just change the scale. I'll have a look up ahead. All right, we've got clear weather, by the way, so we've got terrain selected, and this is quite appropriate for the area that we are in. I don't know whether you noticed it or not, but I didn't feed this fault. But here we are with a cabin pressure problem, with the cabin exceeding 10,000 feet, which now demands that we go through the cabin pressurization loss memory items. And remember, we talked about this, coincidentally enough, yesterday. Cabin pressure problems and unreliable airspeed problems with jammed pitot heads, many different types of problems attributed to volcanic ash. So just for the sake of this briefing, I hope you enjoy the realism of this. I didn't plan this, but in any case, this is why I'm giving you this challenge and looking at all the possible problems that you could have when flying in an area of possible volcanic ash. All right, we'll continue the flight. And for the sake of this training session right now in the simulator, please disregard the cabin pressure light, but effective in what I was talking about yesterday. All right, so the engine failure drift down obstacle limited, same as per normal. So if you have to descend, as we are here in this situation that we've had come up, all of a sudden, remember that where we are, let's have a look here, in our position, that the minimum altitude on our track, as we saw, we are okay to descend to 10,000 feet. All right, this area here would be 11,300. This is our position here. All right, so you're always thinking about these conditions or possible non-normals, more than one non-normal. The two fatal crashes of the 737 MAX, we've heard enough about them over 2 years ago. In both those fatal crashes, there were multiple failures. So it behooves us to be thinking always of how would we handle the situation. Right now, we've got a cabin pressure problem, which depicts that we've got to descend in a rapid descent. All right, we're not going to do it, but this is why I'm making this video. All right. We've got lots to talk about, and we'll do that in parts 2 and 3 as required as we go. So let's go to the next statement that this company has issued for both the VAT underflight and overflight cases. The flight level restrictions should provide ample margin in the case of TCAS RA. There is no change to TCAS SOPs. So that's something that all companies would be wise to adopt. ATC procedures. ATS providers should inform pilot of the presence of volcanic ash before the aircraft enters or operates in such an area. And the following phraseology should be used. You are about to enter a notified volcanic ash temporary danger area in your 2 o'clock position up to flight level 355. Report your intentions. ATCOs and FISOs are not required to question a pilot's approval. You follow your company SOPs. There is no requirement to terminate or amend the ATS provided. This is called airmanship. On receipt of such information, crews must immediately request clearance to remain outside any airspace defined by VATDA. Areas of medium concentration here, the next higher level of, and as defined with an agreement from the original equipment manufacturer. The volcanic ash concentration charts depict the AMC as a gray area. This is advisory only and does not coincide with the area described in the definitive NOTAM. Boeing and the manufacturer of the engine type operated by the company have agreed that flight through AMC is acceptable without a time limit, provided any visible ash cloud is avoided. Flight by this particular company's aircraft through an AMC is permitted under the following conditions. Any visible ash cloud will be avoided. At night or in IMC, avoidance will be by means of monitoring the position of any visible ash cloud and its forecast movement. This will be accomplished through specialist NCC's FOSs. Flight planning using all available sources of information to satisfy this requirement. These will include VAC modeling, direct satellite imagery, if you have it available through your company, SIGMETs and PIREPs. As an additional measure to reduce the probability of an ash encounter at night or an IMC, flight with an AMC will not be permitted within 540 nautical miles of active volcano. Important. Study from conducted by GE can be determined that there has been no known volcanic encounter by an aircraft that reduced in an engine in-flight shutdown or significant operational impact outside of 540 nautical miles. This is important. You don't want to be flaming out with engines, either one or both. All right, so good, Jen. And then there is the area of low contamination. And flight level 200 in green dotted lines for flight level 200 and flight level 350 on the advisory charts. So this is information that you want to consume and be well-informed, especially in flight planning. It is considered prudent to minimize flight time in the ALCs if possible. Therefore, aircraft should climb above and descend through these areas without undue delay. The descend through this is what's recommended in the QRH, one particular circumstance, and we'll look at that in a while. This company has enhanced, standby one. All right, we're flying our airplane here. We're still fine. We know where we are, and we are tracking our flight. Just change the scale here on this beautiful software as we can observe during this briefing. All right, let's go back to what we're talking about. Company aircraft planning to operate with in or over the ELC must not depart utilizing any of the following alleviations. This is one particular company's MEL requirements, and you'll find that most companies, if not all, would have the same. Main engine blades have to be operating. Air conditioning packs must be operating. All of this is operative requirements. Their data computer, standby instruments, APU, and bleed must be serviceable. TCAS, GPWS, and oxygen system for crew and passengers, most certainly, as we have just seen here. All right, let's take a breather. This is the end of part 2, volcanic ash. See you in the next video. Thanks for watching.